Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there. Alright, hey everybody. I hope you've all had a good day so far. Yeah, I'm here at a different time. I think, I don't know, this week, maybe it's been a message from the universe, but I've had something going on like every morning, so I haven't been able to stream during my normal time. So I thought I'd try this afternoon time, and I don't know, maybe it'll be easier to be consistent on. So I don't know, we'll try it at least for today and see how it goes. But yeah, I'm going to stream some more Tessellation Shaders today. We've since last stream I've actually had time to do quite a bit. So I imported some more models in here. Yeah, so tessellation shaders are basically a shader that you can use to generate extra vertices on a mesh. So here, for example, so this is what the meshes look like with no tessellation. And then if I set the tessellation factor to 3, you can see that's it's added a bunch more vertices and edges. And it's cool because I have like again, if we set it to 1, you can see like with a normal map you can kind of add detail to the faces of a mesh, but there's no way you can really affect the silhouette of a mesh. It'll always have these pointed ends. One second. I just noticed my mark is a little messed up. All right, so yeah, like I was saying, you can see the meshes always have these pointed edges here, but we can use some different algorithms to straighten or to curve those when we tessellate. So again, this is it with no, like it doesn't happen automatically. We have to write it. But like this is one way to do it, and then you can use a way called Fong Testilization, where you kind of use the normals of a mesh, and it's pretty inexpensive, but you can see it usually overshoots the actual silhouette a little bit, so you can have this factor to kind of bring it down a little. And then there's another one where we actually calculate something like a Bezier curve, and this one, at least for this sphere, it seems to be pretty much spot on. It does kind of have some issues with other meshes like this Suzanne monkey from Blender. You can see here where like there's a sharp edge, the smoothing kind of messes up the well, it basically makes holes in it, and it doesn't look so good around the eyes either. There's ways you can get around it, which we might investigate, but it might be a little bit out of the scope of my tutorial, so I don't know if we'll deal with it too much. And then I also, this other way, we also try to smooth out the normals even more. You can really only tell on the monkey. Let's turn off the wireframe, and then you can see if we switch between linear normals and the cubic normals, it gets a little bit more detail, but like I said, this monkey model is not really built for tessellation. So yeah, I might need to find something better. And then I also implemented a few different optimization techniques. You can kind of tell when I was looking at the monkey, I don't know if you can all see, but over here, this triangle kind of disappears every once in a while. And that's because I have my own like frustum culling. And the reason you do that is because the GPU actually, like the GPU will automatically throw out pixels that it doesn't have to render by clipping by the camera's frustum, but it won't do it for tessellation automatically. So I test to see if a triangle is out of bounds before we tessellate, and you can just set the factors to 0, and then it just won't render that triangle. And then the last thing I've done since the stream is I implemented a way to kind of change the tessellation factors dynamically. So if we set it to by world, it tries to tessellate edges by their like world length. So here it'd be one split for 3 unity meters. So if I set it to 0.1, then you can see it's splits quite a bit more. And then I have screen space tessellation, which goes by pixels. So here it'll tessellate for every 32 pixels on the screen. There's something about this that, I don't know, it ends up not looking super good. I don't know. You would think that screen space would be ideal, but well, it's not too bad. Let me see. I was getting some weird divots. Oh yeah, like right there. I think it's just because the edges that were behind there were like highly untessellated, so it was kind of not interpolated very well. Oh my gosh, this is the third spam call I've gotten in the last 30 minutes. Okay, we'll just ignore that. And then there's this last one, which is basically world length with kind of a multiplier based on camera depth, which I think this one I think works the best, at least that I've tried. Although it's really dependent on like the mesh. Like for example, this ground mesh, it doesn't really need to be tessellated. So it'd probably be better if we had a different material for it, but everything's just using the same material for now. But you can see when we zoom in. Okay, so yeah, the factor is just too high. But the idea is the farther you get, it shouldn't tessellate as much. Is there a bug? Okay, no, it was working. It's just maybe not. The factor was just too small. I almost think it doesn't, like it's not strong enough. Let's see, so what it does now is it multiplies the distance from the camera with the tessellation factor. Okay, so the farther distance, basically, it just takes that just means that it takes more length to double the tessellation, so I guess we could do like a squared distance, which would be the dot product of these two. That might do the opposite of what I want, but oh, okay. Yeah, and then I needed to do a max here so that it never goes below 1. Okay, so this is obviously wrong. Yeah, because the dot product, this could be, oh yeah, this could be negative. So that's what this problem is. Actually, yeah, the dot product, okay. Yeah, dot product's not the right thing for this. Basically, we just want the distance between this. Okay, so what I was trying to do was distance squared. But yeah, I'm getting all my math confused here. But that would kind of do the opposite, right? Because then the farther distance would increase this tessellation factor. Well, maybe that would work. Let's try it out. You just not do any fancy math and I'll optimize later. Okay, so now if I just increase the factor, Or I guess lower the factor. It's a little better, but I don't know. I feel like... Yeah, I just kind of feel like it's not responsive. As responsive as I want it to be. Like I kind of want it to tessellate quicker. I guess this does the job. I just have to mess with the factor. If we really wanted to, we could also have a tessellation like distance power or something. I don't know. That's really worth it. Because that would increase... Using a POW function is a lot slower than just multiplying something by itself. But anyway, yeah, we can keep playing with this, but this is basically what I've done since the last stream. Still got more to do. So what I thought, it'd be kind of nice if we multiplied the vertex color with the tessellation factor, so that way you could vary like the amount you want tessellated over the mesh. So that way, like for this monkey, you could say you didn't want anything tessellated that's close to one of these sharp edges. There's other ways you could fix this problem too. Like you could make another like edge loop around that's really close, and then the system would know to kind of keep this sharp edge. But yeah, I think I'll play around with that later. But I think what I want to do today is I want to try to render a height map using tessellation, and it's relatively simple. Basically, you just would tessellate a plane, and then in the domain function you sample the texture, and then you can offset the tessellated vertex by that amount. Okay, so let's go ahead and try that. So what I'd like to do is basically all the stuff that I've, like this entire tessellation system, it'd be great if I could put it in its own file and reuse it, because it'd be cool to still be able to support like all these different tessellation modes, and it's kind of independent of like what the file is or yeah, like what the shader is actually doing. So we might take a little bit of time to figure that out. All right, so let's just create a new Hlsl file here. Might rename this, but okay. We'll start off by doing, a normal little define gate here so that it's not included twice. And basically this just says if this keyword is not defined, then run what's inside this block. And then we just immediately define it so that means that this code will only ever be executed once by the compiler, or included in the file once by the compiler. Okay, so let's try to pull out anything in here that has to do with tessellation. Okay, well, before I do this, let's actually save. Let's like work in a branch, so that way if I mess something up, we can just revert. Okay. Alright, so this will be we finish tessellation, smoothing, and variable factors. Okay, so we'll create a new branch. Let's just call this, I don't know, common file. Okay, so now I can, work destructively here and I don't have to worry about losing information. Okay, so this, well, basically, if we have the different Bezier smoothing types, we have like a different number of control points. So the easiest way to deal with that is to define like a constant number, because arrays in Hlsl, the links have to be defined at compile time. That's what that does. Let's see here. Okay, so this tessellation control point needs to be in this file, like in the main file, because it might need to pass things from the vertex to the fragment function. Probably, I mean, the tessellation factors could also maybe go, but okay, let's see. Maybe a good way to do this is we can define another macro. Let's see here. Something like, so basically if we're using a Bezier smoothing, we need to have some more, or an extra field in that control point structure. Okay. I don't know, might rename this, but and then if neither of those are included, then we could just have like an empty define. So I should be able to include, oh yeah, I guess I could have done this a little better. So it's, so I can just say that if the number of Bezier control points is greater than 0, then we have to have a Bezier position, or Bezier. I keep switching back and forth between pronunciations. Okay, so let's test to make sure that everything works so far. So we'll include tessellation common. Okay, we're good. Okay, so this is exported from the vertex function. Okay. So what I like to do so tessellation common. So I mean, the easy thing to do would be to just have like this patch constant function be part of the common file, so that I don't have to figure out how to get it to recognize this structure at all times, but at the same time, it would be nice to be able for the shader to be able to include custom logic here. So, okay, we'll just have to think about that. So, yeah, basically all of this stuff I want to be inside our special function, our file. So we'll remove it. Okay, but so the reason don't know what to do is because it doesn't know what this file is or what this structure is, because we include it at the beginning of the file, but then the structure is defined afterwards. There's a couple I could use. I mean, I guess kind of the easiest way would be if we made a structure that just had like the world space, clip space, and normal of each point. The only problem is then you'd have to create it in this function, which is kind of, I guess, more trouble than I was hoping. But I guess, okay, I guess we're just gonna have to do that. So struct, let's see. Okay, so what else do I want to include? So I want to include this stuff as well. And ideally, we would, I guess we want this as, but okay, so this part won't be in the height map rendering because it's actually different. So maybe we really don't need the Bezier stuff. But I guess it would still be useful because like if I had a shader, like this shader is doing a PBR lighting algorithm, but if I had another one with a custom lighting algorithm, then we would want to also be able to use this smoothing code. Okay, yeah, I guess I'm gonna have to do this. So just be, we'll call it patch point. And yeah, we'll have float 3 position and world space, and then we need the normal and the clip space position. Okay, so instead of doing that, we would make this an array. Okay. And then, yeah, I'm kind of annoyed that I have to do this, but in here we would just need to convert this to a patch point array. And unfortunately, we can't really do that in the file, so that'll have to just be some kind of verbosity. I guess it's in the normal file. But okay, so all this is it's common. So although wait, okay, so this code also, our file also doesn't really know how tessellation factors are defined. So we're gonna just need to return this information. Okay, so let's see. Okay, and then we'll also have to have another file that returns an array. This is kind of rapidly starting to not actually, well, I mean, I guess it does encapsulate a lot of the logic, but it's not going to be very pretty. Well, actually, let's see. You can return its edge. Well, maybe you could pass the array. I'm not sure if it would actually set it to the structure or not. Could also just use macros. Because the good thing about macros is it doesn't really have to know about the structure ahead of time. So maybe that's just what I'll do. Okay, so now what I'm thinking about is I would also like it to return a Boolean so that we know if like this patch was clipped in case we had to do some other logic in here. Maybe what I really should do is just kind of have this standard function, and then if for some reason I had to, some other code had to reuse it. Although wait, so the height map one doesn't need all this Bezier stuff, so I don't know. Yeah, this one kind of complicated thing about shaders is it's sometimes hard to share code between them, but I guess we could also just include this file after the structures. Okay, well that's not going to work either because I was going to say if we include this file after the structures, that would kind of work because these structures would be defined, but the tessellation factor has to already know this macro. And then that also like tightly couples this file to these specific structure names. but I don't know, that might be okay. I think I'm gonna have to, I kind of wanted to do this before we move to the other shader, but I'm gonna need to think about this. I mean, I guess. I mean, because if I just included these file or these functions, I guess that's okay. But again, they have to know about the structure. Okay. Yeah, I don't know. Let's circle back on this later. It's not that interesting to to look at on stream, so I guess I should commit what I've done, and then we'll just do the height map for now. Pull out some functions. Okay. Oh, so this actually did exist. But we don't need that. All right, so let's just make, I don't know, we'll just do another simple shader. So this will be tessellated height map. All right, let's see here. I guess we'll want this. We don't really need this wireframe smoothing. I don't think I'll worry about the actual rendering on this for now. So we'll just have, yeah, just a basic color. Okay, and then we need the height map. I did that correctly, right? Yeah. Okay, yeah, so now we need the Hlsl file for that. Okay, so let's do the define blocker here. All right, so The wireframe tessellation is simpler, so we'll start with this. Okay, yeah, so we'll have position. I guess we'll need a UV. Will we need normals? I guess so. Having like a normal map would make it nice. Okay. Now that I think about it, maybe we should. Well, let's just do it really simple for now, because we might want to have like a normal map and stuff later. Although technically we can, yeah, we can actually derive the normal and tangents from the height map, so might not need it. Okay, and then control point, we have the tessellation, and yeah, we'll also pass the UV. Okay, and no geometry here. And we'll just basically pass through the text chord. Okay, yeah, we'll go ahead and convert that to world space. I'm not sure. I mean, I guess we could go ahead and already convert this to clip space. I'm not sure if that messes up the tessellation position, so we'll leave it like this. That would be something to test, though. Okay, so yeah, we have that, and then we have the color, and then we'll have the texture. Okay, I guess, yeah, we should also have the scaling, which I should technically put in a buffer. Yeah, I guess we can go ahead and include instancing stuff in here. Okay, what else? Oh yeah, and then the C buffer. If you wrap arguments in this, or not arguments, property variables in this, then they'll be ready for the Eurp, yeah, I guess batching. So it's always a good idea to do it, and it's pretty simple. Okay, so what I want to do here is output world space position. So position inputs. This is a Eurp function that is pretty useful. It goes ahead and calculates position and I think world, view, and clip space. So might as well just go ahead and use that. Okay, so we have that, and we can just. I don't know if you could hear that. Something fell downstairs. Okay, yeah, so we have position, okay, and UV. Okay, we'll use this transform text macro, which applies the scaling and tiling from the texture importer. Okay, so that's all set up. Okay, so we have our tessellation factors. We'll just do a constant factor for now, which I did set there. And okay, so I have all these defined so we can switch between different partitioning methods. I guess we can leave that. The whole function doesn't need anything else. Okay, so the domain function, we interpolate world space positions. And then I need to, okay, so I actually don't even care about the world space position. The interpolator doesn't anyway, but we need to still compute it and then output the clip space position, which is, again, just the position of the vertex, or the, yeah, I guess this vertex on the screen. World 2H clip. I think this is the right function for it. If not, we'll soon find out. And then I just need to pass the UV through. You can also interpolate it with barycentric coordinates, which is basically just, I guess, coordinates on the triangle. Okay, and then I don't need all this stuff about the geometry function. That was the wireframe renderer. And for the fragment function, yeah, I guess we actually, now that I think about it, the fragment function doesn't actually need the UV because we actually only need the UV to sample the height map, which we would do in the domain function. Although I guess if we ever do have a color texture, we would want to sample that. So I'll just leave it for now because we probably will add a color texture. So for now, we'll just return color. Now that I think about it, this code doesn't even include a shadow caster or anything, so we'll have to add that. Not that it's that difficult. Okay, so that's good so far. Let's go ahead and switch to another scene. Okay, I'm gonna, it's already called sample scene. That's kind of annoying. Let's change this to lit tessellation test. And then hopefully it'll let me just change this folder as well. Okay, and then we'll make a new scene. And I'll call this one height map test. Okay, so let's make a plane. Create a material for it. I was gonna say, yeah, I didn't assign the rendered one yet. Okay, and I think in the height map shader, yeah, I didn't change the name, so let's change it to tessellated height map. Okay, so one thing, yeah, this shouldn't be black, so what's the deal with that? Unless I named it wrong. Okay, maybe yeah, I had it right before I capitalized it. Okay, no, that's not the problem. Oh, why is it not throwing an error? Oh, because the tessellated, yeah, the shader also includes the wrong file. So tessellated height map. Yeah, because it's going to throw an error now. Because yeah, I left and this still outputs geometry input, which it should output interpolators. I don't know why this keeps coming up. It says use of. Oh, okay, so it's complaining because sometimes the Bezier points might not be initialized. So I guess I could just do this. Just to get rid of that error. Okay, transform world to H clip. Okay, so that's not the right function. We can just look in the tessellated lit shader because I also do that here. Oh. Must have just made a typo. Oh yeah, and then I need to remove the geometry. Okay, so now if I increase this, it should tessellate it. Does. And then I can switch to different partition modes. Okay, I think integer might be good for this one. All right, so now we need to get a height map. I think, let's see, I rendered a height map. I guess we'll leave this open, but I rendered a height map in one of my grass projects, so maybe we can just reuse that one instead of having to generate a new one. If I can find it. Okay, so it's in this .raw format. Can let's see. It's been a while, so I'm not sure what I used to make that file. Okay, so it wasn't GIMP. Okay, well, we can just use this simpler one, I guess. It's really small, though. Doesn't really have much variation. Don't I? I know I used one, but I guess it's just not here. Maybe it's in. I don't remember what. Nope, not here. Okay, it's probably that raw file, what I'm thinking of. Because I think I had like use GIMP, or not GIMP, Blender to output the specific. Oh, here it is. Hlsl height map output. Okay, well, I mean, it's not that impressive, but I guess it'll work. So I don't think this is it, but we'll go with it. Anyway. Okay, so nothing happens right now, obviously, because we don't sample the texture yet. So what I need to do, okay, so we need to actually have like a height. Let's get rid of that, so we don't accidentally mess it up. Okay, so this is like the height that will, once we sample the height map, we'll multiply with this to transform it to world, I guess world height. Okay, so we have the world space. Now we need to sample the height map. So first we need to interpolate the UV ahead of time, so we can grab the correct pixel out of the height map. So float height map sample texture. I always forget sample. I think that's the correct syntax, but it'll let me know if it's wrong. So we pass it the height map, the sampler, height map, the UV, and then we gotta give it the LOD, which will just do 0. Which LOD is basically the map level. We have to use this LOD instead of just normal sample texture 2D because sample texture 2D uses partial derivatives to calculate the map level, and that's not available outside of the fragment function. Okay, and then we only need the red component. Okay, so the actual height, I guess we can just go ahead and multiply. So what we really want to do is multiply this, or add this height to the position based on the normal vector. So I guess we will need the normal vector after all, which I kind of thought, but. Do we need, I guess we don't need a tangent because we'll be able to calculate, because we can calculate tangent vectors and like lighting normals from the height map itself. But we need the actual mesh normal to, yeah, serve as like the base for it. Yeah, so we'll also have to pass this through to the interpolators. But yeah, we will need to do it, but not yet because I'm not worrying about regenerating the normal map. Okay, so we'll pass world space normal. Okay, and then we can also convert normal vectors using the same or another built-in function. And this one, like if you do have the normal, I mean a tangent, you should pass it through because it can generate more values for you, but we're not dealing with that right now. Okay, so now we have this height and we'll multiply that by the normal. Let's see. Well, before I do that, I need to interpolate the normal vector over the triangle. And yeah, I also have to normalize it. So it's a unit vector. Okay, so finally we can add position world space plus equals normal world space times height. Okay. Oh, I always do this. It's vertex normal inputs, not normal position inputs. Okay. So this is saying whenever you have an error that says no matching zero parameter function, usually that means that the argument inside has a typo. Or it doesn't recognize the variable. But okay. I added normal to that, right? Okay. Did I make a typo? Unexpected token. Oh, right. I don't want the semicolon at the end. Okay, there we go. Okay, so now we can kind of see it's already starting to render some height. Yeah, we can increase that a little more. And then if we increase the tessellation factor, it will get more and more fine-grained. Do I have the clipping turned off or something? Because I can like see through the mesh. Okay, no, it's just normal clipping. It must just be the way that the wireframe is rendered. But of course, yeah, if I don't have any shade, if I have the wireframe turned off, we can't really see what's going on because there's no lighting to the actual height map. So yeah, we definitely need to fix that. Yeah, so I guess we'll move on to that. So, okay. I guess the first order of business is we need to, well, I guess I kind of have to copy this stuff and then we'll have to generate what we need for it. All right, so let's just copy this whole pass. Now that I think about it, I forgot to handle the instancing that I talked about earlier. Okay. Okay, so for the depth normals, we're definitely going to have to... Normally you would just pass through the normal, but I think since we've like deformed this so much, we're definitely going to have to pass through the pixel generated normal. So, how do... I mean, we could just calculate the normals here, or we could calculate the normals per pixel. I guess it just depends what you want to do. I kind of want to do it per pixel and just see how that looks, and maybe we can have a keyword to switch between and see what looks, if it really makes that much of a difference. Okay, but anyway, so I'll need sample all the, we're gonna go full lighting. I guess we might as well go all out. So let's see. I guess I'm not gonna worry about our alpha cutout. Okay, so we'll have the main texture. A lot of this stuff, but not everything. Obviously, we won't really have a normal map because we have the height map instead. And yeah, the height map won't have a scale and offset anymore because it'll just be part of the main texture. Yeah, I want to alpha cutoff. I guess we'll still have this data map. Yeah, then we'll have multiplication or multipliers for the lighting information. Okay. Yeah, so we don't require geometry anymore. We need to include a bunch of stuff here for the lighting. Yeah, basically these are all lighting keywords. Okay. Yeah, and then we'll have this special keyword just to let the compiler know that we're in the forward lit pass. And I'll go ahead and copy all this stuff for the shadow caster and depth. Okay, yeah, we'll have to deal with the meta pass as well, but all right, so we don't have this stuff. But yeah, these will also need all the partitioning keywords. And then I need to call the correct, or include the correct file. Okay. I'll just let it use the same meta pass for now. Okay, so in here, what do I need? It's all pretty simple, except I need to get the shadow caster information, and then we'll need this view. Yes, this is more common stuff. I'll just kind of copy and paste stuff for now, and eventually I'm going to need to clean up these files, but okay. So then when we generate the clip space position here, we'll also need to make sure that if we're in the shadow caster pass, that we use the new shadow caster function, and this just also includes the shadow biases. Okay, so that's good. Oh yeah, I need to include all the new properties. Yeah, instead of normal map, just gonna rearrange it so it'll match the order that's in the texture file. And then we'll have height multiplier. I won't worry about frustum culling for now. And yeah, no alpha cutoff and no normal strength. I guess this can go there to kind of match the order in the shader file. What else do I need to do? I guess, yeah, in the vertex function, we have to also pass, we need to like pass the lighting information. So what else does it need? I guess it just needs the vertex lighting and the light map UV. And then yeah, here is where we need most of the stuff. Okay, what else can we do? Also, yeah, here we can actually return even sooner because for the depth, yeah, since we don't have this alpha cutout, we actually only need color and the lit pass. And then, yeah, we'll just return 0 in the shadow caster and depth only pass. Okay, so we'll come back to that. What else do I need to do? I need, in the vertex, I need to get the light map. Here's that. Okay, then here I need to pass the rest of the lighting data. Okay, so now actually the UV only has to be passed certain times. Okay, so this keyword is a little bit of a misnomer now. What should I call it? Because we need it whenever we're gonna calculate normals. Let's see. Okay, so I guess we'll need it when we need to calculate normals in the fragment function. So where's normal calc? Let's do it this way. Oops, I did it backwards. This goes there, and then this goes in the top. Current document, okay. Okay, so yeah, we don't have a tangent vector anymore. Because the tangent vector... Do I still need it? Well, no, because yeah, we don't really have a normal map. So yeah, I don't think I need it. We'll see, I guess. Okay, so that means I can bring these down to use a different text chord register. Get rid of that. Okay, so now Let's I'm gonna simplify this and just have it return the main sample. Just to test. And then yeah, this is actually wrong as well, so we'll just pass black for that. Okay. Height multiplier. Okay, so it's working so far. If I make another plane, do I get a shadow? Okay, and I do get a shadow. All right, let's see. I guess so I need to get this lighting work complete. So first of all, I need to calculate a correct normal. So this would happen if this is true. Okay, so if we're going to recalculate normals in the fragment function, first we need to sample the height map again. Okay, and this time we can use bitmaps. Okay, let's see here actually. P equals input.uv. Actually, I don't think I need to sample this. So what I have to do is I need to sample the texture 4 times, but like around the center. And then we take the cross product of that to generate a normal. So I need a Tessellation size for the texture. Which Unity will just automatically fill that vector. Or, yeah, I guess that's a vector. But I forget. Is it? So I think the XY have the size of one. Let's see. Like, okay, so 2 variables have the X and Y like size of one Tessellation in UV units. And then the other one tells you like the total number of Tessellation in the texture. I forget which one is which. I think XY is the size of a Tessellation in texture unit or in UV units, which is what we want. Okay. So I guess to simplify this. Okay, so we need to create 2 tangent vectors basically. So we need to sample the textures to the left and the right, and then the above and below. Okay, so let's see here. Hopefully I can do this correctly. The left is 3. So it would be... Okay, so I've got to somehow... Okay, well, I guess we know the world position of the fragment. How can I figure out the size? Like this size in world space. What does it even... matter. I think I tried to do this on stream before and we ended up having to like use a helper script. Maybe there's a better way to do it. Let's see, so generate normal from height map. I don't want to make a normal map. Okay, this one sounds right. Okay, yeah, so I know like the logic of it, but the problem is these are different values because like I don't know why they could just insert a 1 there. I guess they kind of know the size of their pixels, so that's it's gonna be kind of annoying to figure out. Because I know height in world space, but I don't know the X and... Well, okay, let's see. I guess we could just generate the whole thing. I was gonna say in tangent space. Because now that I think about it, it's gonna be even a little bit more complicated because we've got to convert this from tangent space to world space. So maybe I will need that tangent vector after all. I think I will actually. Okay, so this is going to be kind of annoying to do. Can I Unity get world size of a Tessellation? Okay, yeah, so basically that's, yeah, we've got to figure out the bounds of the mesh and then okay, yeah, so we're gonna have to do that with a script or something. And now we're gonna need to bring tangent vectors through. Oh yeah, I also need to include the bitangent multiplier, which is stored on the fourth component of the tangent vector and the input structure. kind of confusing, but so okay, yeah. If my stream cuts out, I do apologize. We've had like really bad wind the last couple days, and it's picking up again, and my power actually went out yesterday because of it, so. Okay, so again, we've got to pass that through. And I think, yeah, so I need to add back in the tangent vector. Okay, so I guess it's going to be a little bit more complicated than I hoped. For now, I'm just going to use we'll just use the interpolated normal. Yeah. So we'll need this stuff, so I'm gonna copy it up here so we don't lose it. Okay, so this should all be fine. Oh, except I don't know why this needs the normal tangent space. I don't think it ever actually uses it, but we'll just go ahead and define one, because technically it's just this vector right now. Tangent world space. Oh, yeah. It's just object space tangent. No, this generates the tangent vector. I've used that before, I know. Let's see, vertex normal inputs. Yeah, so when you pass in the tangent, it generates it right there. So what's it complaining about? Oh, maybe. Oh no, I did make it a float 4. Invalid subscript tangent world space at 106. Oh, did I not put in the output structure? That's probably it. Yeah, it's not there. Incorrect number of arguments to this. Oh, yeah. Needs to be a float 3. Okay, so now it should work, but I don't think I have a any texturing on it. Okay, so why is it black? That would imply that there's no lighting, but I guess let's just pass through the main sample. Okay, so since I passed the main sample and it's still black. Oh, maybe I didn't. Something's wrong here. Pass through the tint and see if that goes through correctly. Oh, okay, I don't actually return the color, I just return black. Okay, there we go. Okay, so now it's gray, and then if I set this. Okay, so we can see. Okay, so we're getting some shadow acne there, and that's probably because the normal isn't right. And that's definitely because the normal isn't right. So that means I do need to recalculate the normal here in the domain function. That's going to be a little difficult because I don't know the barycentric coordinates of my neighbors. So what I would normally do is I would take the vertices of my neighbors and then calculate like a flat normal. But I guess so what we're gonna have to do is just do this normal calculation code in the domain always, because otherwise we won't get I guess the shadow caster will be messed up. And then we can just, well, I can either recalculate them again in the fragment function or just interpolate between them. I guess that would be the keyword. Okay, so that means probably we'd only need the normal and the shadow caster pass if we have fragment normals turned on. Okay, so that's a little confusing, but we'll I think I'll optimize that later. Okay, so let's see. Yeah, so this happens mostly if the normal's wrong, because the shadows in general are just kind of a pain, but if the shadow bias, like how do I explain it? I guess when Unity generates the shadow maps, there's a bias on the normal so that when you sample the normal later, it doesn't like show up on that model that casts the shadow. But if the normal is incorrect, it can be pushed in the wrong direction, and then you get this kind of thing. I guess just to make sure that this is it, if I change the normal bias, yeah, it goes away. But the problem is if you turn it up really high, you start to see other strange artifacts, like the shadow is far away from the actual caster. I guess you can kind of see it right here. It's a little difficult to tell, but you can see that the shadow actually ends before the mesh touches the ground. That's just because the bias is really high. And you can see it changes. But when we get to 0, then we get even worse. Another thing I noticed is that, okay, yeah, so I thought that would happen. Also, we can see when you click on it, Unity thinks the bounds are down here, so when the mesh gets off screen, it's going to hide the model. So I need to change the bounds. Unfortunately, maybe you could do it. I don't know. There was some weird thing with bounds, like you couldn't set them, and they finally added it in 2021.2. But I can't remember the specifics. Let's change a note. Set bounds. Let's see. CPU side bounds. We'll figure that out at some point. I guess we're already gonna have to have a script to calculate the world space Tessellation size, so we can just do it in there. Okay, so speaking about that, we're gonna need to calculate it here. Okay, I think it's gonna be easier to do in the fragment function. So I think I'll do it there first, and we'll just ignore the shadow problem for now, and we'll come back and fix it. Okay, so basically what I need to do. Okay, so we need to create left equals negative. What was it? World space pixel size. Oh, wait. So I'm generating this in tangent space. I guess this is still right, because tangent space is just rotated, so the sizes would be the same. Okay, and the y is 0, and then the z is the sample height at uv minus flip 2 main texture dot pixel size x 0. Okay, and then the right is the same thing except positive. This should be flip 2s. Why is the... Okay, I think I forgot a parenthesis. Yeah, I could tell because the rainbow brackets are messed up. Okay, now up. This might be backwards. I forget if up on UV is positive or negative. I think it's positive. So I guess I should do down and then up, just so it's symmetric. Okay, so yeah, it's actually 0, and then y. Okay, so now we have 3 vectors, and we can just take cross product to find the normal. So normal tangent space equals cross product right minus left and up minus down. And then we'll need to normalize that. Okay, and then we can convert that to world space using this tangent to world multiplication. Okay, so that should be it. Just for testing, I'm gonna quickly make this available here. Okay. Valid subscript textile size. Oh, yeah. It's an underscore there, not a dot. Create tangent to world no matching 3 parameter. Okay, so something here is missing. Okay, so I have the normal and the tangent, right? Yeah. And I included the Eurp. No matching 3 parameter function. So let's see. Let's just try and figure out which one is null. Okay, so we should get an error on one of these lines depending on which one it's complaining about. Okay. Over here it says invalid subscript W. Okay, so maybe the issue is this tangent is a float 3 and it should be a float 4. Okay, I guess that was it. Okay, so the first thing I can tell is I think the normal vector is upside down. If I turn off culling real quick, it should be pretty obvious. Okay, no. So let's just output the normal. Oh, yeah, I need to add another component to it because there's no alpha there. Okay, so the normal is black. So that could mean it's negative or 0. If I set this to negative, what does it show? Okay, so I guess it's 0. Oh, you know why? It's because... okay, let's clean that up. It's because the... Oh. Well, I was going to say I thought this was 0, but it was actually not. Okay, that's a little disappointing. I'm gonna to make sure this isn't like make sure this is set. Okay, no, so it's not being set. Did I copy the name wrong? Oh, this is a float 2. And then here it's just a float. So maybe that was the issue. Okay. So yeah. Okay, so it is listening to that. Okay, so let's also make sure this is being set correctly. Should just be like white or something. No. Oh, right. Okay. I guess I should make sure, yeah, what value is actually in here. Because like I said before, the X and Y and then the ZW are different. Okay, yeah, so it's the size of 1 pixel. The X and Y is the size of 1 pixel in UV space. And then that's the width and height of the texture. Okay. All right, so now let's output normals again and see. Okay, so it is actually generating something. I don't know if it's correct or not, but let's look. So green is up, so it's good that it's mostly up. And then yeah, on slopes this way it is bluer, and then on slopes that way it's yellower. I think in general it's too green, but that's probably because this value is too high. Yeah, something like that. Oh, it's got these weird. Oh, I think that's the pixel boundaries. That actually kind of looks cool, but yeah, so we can see this textile size really makes a big difference. So we need to generate something to find the correct value, but at least we're getting somewhere. Now if we feed it through the PBR, we should get some lighting. And then if we tessellate more, let's turn off the wireframe. Yeah, we can see it roughly matches. So it's kind of working, except it's just the scale is not right. Because it shouldn't. Yeah, we just need this textile size to actually match up. I mean, I guess we could just let the user define it, but I mean, if we could do it in a script, why not? Okay, so let's create that script now. So height map. Let's do tessellated height map. So support. Okay. Let's see. So void start. Let's see. So it will need to get the mesh. Let's do this. So renderer equals get component mesh renderer var filter equals get component mesh. Well, I guess I won't really need the filter. I'm not gonna modify the mesh. Okay. Actually, I don't even know if I need the mesh period. So renderer bounds. I don't think I can set the bounds yet. Yeah, you're finally able to set that in the newest version. Yeah, this is 2020.3 like I'm working on. Okay, you can override the default bounding box by setting your own world space bounding box. This is most useful when the renderer uses a shader that doesn't custom vertex deformations. So, okay, well that's fine. We just won't be able to set this. All right, so now what I'm thinking of, don't we have all those different Unity versions? Okay, we do. So we'd want 2021.3 or newer, but it doesn't look like we have it. Maybe it just isn't known about. Okay, but anyway, I'll just leave that there so it'll throw an error and I'll remember to add it. Let's do set CPU side bounds in 2021.2. Okay, so now what we need to do, yeah, we need to get the global bounds of the mesh. Well, I guess, no, we don't really, we need to do the local bounds and then we need to multiply it by, I guess we kind of do, because we have to rotate. Yeah, so what I wanted to do, okay, I'm going to get a piece of code that I've used a lot that transforms local bounds to world space. Let's see here. Actually, I think I used it in this. And my grass camera. I guess I didn't need it here. I know I used it in my compute shader, so let's look there. Let's look there. Yeah. Okay, so we can reuse this again. Yeah, so basically it just transforms the bounds from object space to world space, which is nice because we want to take into account. Oh gosh. I don't know if you can hear that, but I think the Amazon trucks around here have this like new, like, you know, how trucks make this sound when they back up. They have this new one that sounds like, I don't know, like scratching on a chalkboard or something, or a really hoarse duck. But anyway, it's always a little strange to hear. Okay, so anyway, var world bounds equals transform bounds mesh bounds. Okay, so this gives us local bounds of the mesh, so then we got the world space. And mostly what we wanted to do is take care of scaling and rotating. And then we need to add the height for this. So yeah, basically we need to expand the bounds, which I think I can. There's an expand function. Oh, so we need to get the material out of the renderer. So it's the height multiplier. Okay. What's it complaining about? Oh, I'm missing a parentheses. Okay, so now we have that, and then we can also set the material set. I guess it's actually a vector. What's it called? World space. Pixel size. Okay, so now I need to know the size of the texture. Can I get a texture out of the material? That would be easiest. Okay, I can. I'm actually going to go ahead and cast this to a texture 2D because it is one. I guess I could keep the var there. Okay, so new vector 4. The X is the height map width divided by the world bounds size dot x. Then height map height divided by world bound size dot y. And then the other two we could just set to 0. Okay, and then this would just be renderer dot bounds equals world bounds. Okay, yeah, we don't need that. Okay, so hopefully this should just work. Let's press play and see. Okay, well, it's a lot more subtle than I thought. I hope you can't hear that. Got some yard workers outside my window, but anyway, sorry about that if you can. But so you can see kind of the tessellation pattern. I don't know if there's a way we can really avoid that. Actually, it might be due to the shadow issue. But yeah, okay, so it doesn't run all the time, so you can't really see it change in real time. But so if I change this height, okay, so well, I guess that doesn't change the textile size, but it will change the normal. And here we can see it's a little bit more pronounced. It's kind of strange. Oh, maybe this is. Yeah, so here I've set it to extremely high tessellation. But we still get these kind of weird shapes, and it might be due to compression, now that I think about it. So if I turn off compression, it'll probably look better. It does. You still get some stuff. And it's flipping through the camera a little bit. Okay, so this is all shadow stuff. If I turn off shadows, okay, so if I turn off shadows, it's pretty smooth, but I can't see the normal at all. What's that about? Okay, so maybe it's not working, and all the shading we had was just due to the shadows? Okay, that's kind of funny. Well, that would explain why it looked funny anyway. Okay, let's do this. Okay, so it's entirely green. All right, so we do all that. But it seemed like it did change when I did this. Okay, well, we can... Well, this is wrong. Okay, let's see. Okay, so those are way too big, obviously, because 51... Oh, you know what? I think it's because... Yeah, let's see. Yeah, the height map is in pixels. So... Yeah, so we want this to be in UV space, which is just 1. So is it just the inverse of this? That seems kind of weird, but maybe that's right. No, because if it was small size, then this would be... If the bounds were small, then this would be bigger. Okay, so let's see. I want to calculate pixel size to world size. Okay, so I think it's world bounds divided by the number of pixels, maybe? I think I had it backwards. Let's... Still don't know if that would convert to UV space, but... I guess I could just... Oh, not easily. I was going to say I could just print out what I've done there, but... Okay. Maybe I got it right. Let's see. So yeah, it's definitely bluer on the side where Z is pointing and redder, yeah, where X is pointing. So this might be right. And then does it become less extreme when I bring the height down? Okay, so ideally it would be 0 and height is 0. Okay, so this might be right. Yeah, it almost seems a little bit too strong, which would mean that the value is not correct, but I guess let's look at it with lighting. Okay, probably gonna need this again, so oops. Let's do it this way. So it'll just kind of overwrite that line. I don't know, maybe it is fine. Okay, let's see. Well, what does the sun... Okay, so if it pointed straight down... Okay, that's not right, I don't think. So it was pointing straight down. Yeah, okay, so let's think this through. What I want to do here is I need to convert. Basically, I move 1 pixel over. And okay, so I need to convert pixels to world units, basically, because I move 1 pixel over, which that's what this is. And then I need this to move 1, or basically the same amount in world space. Hi, Odom Toot. Or Odom Toot. Thanks for coming by. How are you doing today? Okay, so let's see. So yeah. So basically this gives me so yeah, if we have so basically if I had 1 pixel here, and then we'd cancel out the pixel units and be left with world space. So this is correct, I think, but it just seems too big. Let's see. Can I turn on grid? Okay, so I think this is 10 world units. I guess it might be easier to test it this way. Okay, well, it's not centered. Let's fix that. This was just for testing shadows. Oh, is the shadow caster not? Oh yeah, I turned off shadows. Okay, that's fine. Then the cube. So yeah, I basically just want to make sure. So yeah, it's 10 units wide. Saw the news on YouTube about the stream. Now you know that I have a Twitch. Oh well, I hope that you are able to come by some. Yeah, I haven't been able to stream super consistently lately, so I'm hoping to fix that. But yeah, I'm trying out a different time slot today, so we'll see how it works out. Okay, so yeah, it is, anyway, it's 10 pixel or 10 units across. I guess I should make sure that the world bounds is correct here. So we do expand by the height multiplier, but let's just print this out. And then I guess I'll move this out so I can print it. So var pixel size. Okay. We got 000 extents. Oh, you know what? I think the issue here is that this world bounds should actually be Z here. Yeah, okay. Yeah, unities. Y is up. Messed me up once again. Is that the problem? Okay. It still looks a bit extreme, but I guess I also do need to remember this is 10 meters long, so these these hills are comparatively big. Anyway, let's actually just export the size here. I don't really care about the other information. Okay, so yeah, so it's 10, 0, 10. Okay, and this says 0, 0, 0, but I think it actually is just not printed out correctly. So we can fix that. If we give it a format, let's see, I always forget. But I think this tells it to print out to 4 decimals. Hopefully I remembered it. Okay, so it's 0 or 0.0107. Right, so how big is our texture? Okay, so it's 1024. So basically what we want is 10 divided by 1024. So let me break out the calculator. I mean, we don't really need a calculator for this, but just to make sure. Okay, so that's not right. It's not the same. It's not like it's rounded up. Okay, so where is the discrepancy coming from? Height map, width. Oh yeah, height. Oh, that is strange. Okay, so this is 10 by 10, 1024 by 1024, but it's not the same. Did I type it wrong? Maybe I just typed it wrong. No? Okay. Huh. Why is it different? Well, let's try. I mean, does this look right? I guess this is how it should look. So if I copy that. Oh, I didn't copy it. And I keep closing the window. Oops. Okay. So it still looks kind of funny. Why is it like that? I mean, it looks fine here, but when you view it straight down, I guess that's just how it is, but I mean, it could be specular and stuff that makes it look like that. Yeah, I don't know why it's like this when it's straight down. Something isn't right. Okay, maybe if I just do something simple. Let's just do the color equals get main light direction. We'll just do a really simple diffuse only. Okay. So it was something about the, yeah, because when I just do it only, it looks a little better now when it's just a pure diffuse lighting. So I think the normal is correct. Maybe something else about the lighting was weird. Although, why is it? Okay, so now I don't think so, because now when this is purely horizontal, this is way too bright. And it stays bright even when I go kind of upside down. So the normal is way too extreme. What is wrong? These vectors is basically world space textile size times 2. And then it's the difference. So it's right minus left. So it's this one minus this one. So yeah, this is the different heights. Hey, thanks for the follow. So I feel like yeah, I feel like it's too extreme. I'm not sure what to yeah, thanks for following Odin Toot. Let me think. Let me just look at the normals again. Yeah, I mean, this is pretty extreme. Let's see, because this is like almost entirely pointing in the Z direction because it's pretty blue. Which you would expect that to be when they're much higher. Or when the height map is a lot higher. So this is like, let's set this to something like really high and see what it looks like. Okay, so yeah, my height map's also not the best because it's not like anchored on 0 correctly, but okay. So the math is, I think the math is right because everything looks correctly. It's just too extreme, like I've said. It's like even this. Okay, so I'm not sure what to do about that. I feel like, because we made sure the math was right. Stuff. Is it possible to recalculate the bounding box of the render when using vertex displacement in the shader? Bounding box of the render. Oh, well, I tried to. So here we do the bounding box and then I just like expand the world's. Oh, you know what? Oh, I think that is the issue. Yeah, thank you for mentioning that, because I think what I've done here is I've expanded the world size to take into account our vertex offsets, but by doing so, I'm also changing the size of the texture, or the size of the bounds that I'm using to calculate the textile size. So this excuse me, this line should go only in here because where we are recalculating the world bounds for the renderer. So that's probably why the math was wrong, but I don't know if we calculate the correct value and it still looked too extreme anyway. Yeah, so now it's finally getting that 0.009 thing, but just grows so much. I wish that there was a way I could visualize the normals easier. Don't think. Like if it had a little arrow that would point, because then I could see if it really is working correctly. How difficult would it be to create something like that? I guess I'd have to make a geometry function. I don't know. It would be a pretty big detour, but All right, well, I think in theory we've got it working, but like I said, something about the scaling is incorrect. So I think I'll need to go and do some research about that. So, but since we've gotten, like, I think we just have to fix the math a little bit. So it's not something super major, but I think let's move on something else on stream, and I'll just do some research myself off stream. Okay, so this should work. Let's see. Fix normal generation. Wrong. Math somewhere. I guess actually the wrong world space. Pixel size. Yeah, we'll deal with that. But okay, so what else do I need to do? Okay, so we've got basically generated our own normal map from the height map. And we've got texture. I guess I can just make sure that metallic and stuff works. Seems like it. What's that site that I have for notes? Oh, it's called Notion. It's yeah, it does have a website version, but I actually downloaded it for on my desktop. But yeah, I like it quite a bit. Yeah, it's I'll type the name, but it's called Notion. Okay. So I think this thing is pretty much done. Besides that math issue, so maybe we'll move on to something else. Let's see. Yeah, it's very highly tessellated, actually. And no problem. I hope you enjoy it. Yeah, I use it for all my project management and tutorial notes. It's really useful. Yeah, I mean, I guess we could add. I'm kind of curious to like have variable tessellation based on like the height or the distance from the camera. I don't know. I mean, it might have some kind of bad pop-in because when you remove tessellation, you change the physical shape of the height map. But I kind of still want to see what it looks like. But to add that, we'd have to do that common file, which I was struggling with earlier. So I think I'll also leave that for off stream. So what else do I have to do? So we'll mark that as done. Besides a few fixes, I'm gonna give myself an exclamation point to, I don't know, let's do, come on, what's it called? Oh, I was looking for that flashing light thing. Oh, there it is. What's it called? Police. I thought I typed in police, but anyway. So yeah, I need to fix this for sure. Okay, so the other big thing I need to do is, well, this one's pretty simple actually. It's basically just vertex lighting, but in the tessellation shader. So yeah, we can try that out. Yeah, this is gonna bother me. I'm gonna be thinking about it all night. Anyway. Okay, so what this does is if you have a really complicated lighting algorithm, you can calculate the lighting per tessellated vertex instead of every pixel, and that will save you quite a bit of resources. All right, so let's start with the tessellated lit shader. Do not copy it. There we go. Okay. What do I want to call this one? I guess let's call it tessellated vertex lit. Okay, so we'll have texture, tint. I guess we'll just keep the cutout. I feel like if you're gonna have a vertex lighting, you don't really want a normal map. Or, well, I guess you could still have a data map. It's just you don't calculate that kind of thing. Okay, let me think here. So the issue is we don't want to call this universal PBR every frame. So basically we want to calculate the lighting for a white color, and then we multiply that with the albedo or the color texture. Let's see, that might not work with unities. Hi, i3. Yeah, it's a lot of shader code. Yeah, I need to clean this up. It's gotten a little unwieldy. Let me think. Oh yeah, I need to. It's in here. So Unity's PBR fragment function. Basically, I want to see if I can somehow calculate it and then multiply the albedo separately. I don't think. Well, I don't know. Maybe it would work. Well, I mean, if you're going to do vertex lighting, you don't really want PBR lighting anyway. So I'm just... Well, okay, we'll see how it looks, I guess. But I don't... Yeah, there's not really any point to have a normal map, I don't think. But I guess you'd still want to be able to vary this over your model, and you can sample it on the tessellated vertices. So we'll leave that. Okay, I'm not going to do any of this fancy tessellation stuff because I need to add that back in later. Okay, let's set this. I don't know. This idea, it sounded kind of cool, but now that I'm thinking about it, I don't know how... Well, I don't know how it will actually look. I mean, technically, I think in order to really show this off in the tutorial, I need to make some kind of complicated lighting algorithm, but I'm not sure. I mean, I guess if you had forward lights with a bunch of different light, where you had to like loop through 30 lights or something, you could do something like this. Oh, yeah, I guess I could. I'm just trying to think. I don't know if it's even worth, like this kind of thing is just not a PBR type thing. You'd only do it if you had some kind of custom lighting or something really strange. Or not strange, just unusual. So I'm just not sure what values I need to include here, but I guess we'll deal with that later. Okay, So I'm gonna start this with a tessellated height map because it's a little simpler. Okay, so why am I using Eurp instead of the built-in render pipeline? Basically just when when I started doing my tutorials, I had to kind of choose what to go with. And I don't know if this is true, but I feel like built-in is going to be deprecated at some point, and Eurp is going to be the new render pipeline, so I thought I would just learn it. Although, yeah, I really miss the surface shaders from built-in. But I've been writing with it now for over a year, so no, I'm just kind of used to it. Okay, so what do I want to do here? I think I'm just trying to think of a good use case for this. I mean, I guess vertex lighting is just a good use case. So let's just start simple and we'll add stuff as we need. I guess we'll still need the normal, but like I said, there's not going to be normal mapping, so I don't think we need the tangent. I mean, I guess we'll just leave the light map. Let's see. I'm just trying to think. Is there like a expensive lighting algorithm I can do? I mean, I guess like I could do the same. Where you just, or do that thing where you have like a bunch of different lights and you loop through them all. By the way, you tried to change Unity Eurp standard shaders, but Unity removed your changes from the code. Do you know what you should do? Oh, you tried to change like this code in there. Like here, and like the lighting, Hlsl. Yeah, I think whenever Unity will revert any changes you do to those to match the packages. So I think, okay, yeah, this is probably not ideal, but I think if you wanted to change something on there, you'd have to duplicate the file yourself, put it in your project's asset folder, and then change any shader that you want to use that to use your new file instead of the original lighting file. Yeah, that's I don't know if it was any better. And well, I guess in built-in you could do it a little simpler, but yeah, that's another downside to Eurp. It's definitely not perfect. Okay, so I think what I'm gonna do. Yeah, I guess we could do. I'm thinking like a Christmas tree where there's like hundreds of lights, and then the lights are actually calculated per vertex instead of per fragment. Well, I guess we'll see. I mean, I can always add the normal lighting algorithm back in. Yeah, I'm just trying to think. Like, I don't want to spend a ton of time working on something that's not very useful, so... Okay. Yeah, I think we will move on with this. So yeah, position normal UV, position normal UV, and no light map. And then the interpolators, we would only pass the UV to sample texture and then lighting. So let's see here. Yeah, we need the clip space. So everything is going to need UV again because they have to alpha clip. I mean, I guess I could just not worry about alpha clipping. Yeah, I guess we just won't. So that in that case, so this would require a normal fragment. Yeah, so and the 4 lit pass would be the only thing that needs UVs. Okay, so let's clean this up a bit. 2, 3, 4. Oh yeah, I don't need light maps actually. Oh yeah, so actually the 4 lit pass only needs UV and then the lighting data. So I guess we can still do fog. So it would be fog factor and lighting. Doesn't need world space position. Okay, so here, I mean, I guess we'll have a data map. It is sampled per texture, but no height map. Okay, so yeah, I'm just gonna get rid of the alpha cutout. It complicates things with no real use. Okay, well, I mean, it is useful, but I don't really need it in this shader. Okay, so we'll have a tessellation, which I deleted by accident. I guess we might as well leave in the tessellation partitioning. Which means I need to add it to all the passes. Okay. Okay, so we still need to do this with the shadow caster. So leave that. Okay, and then the vertex function that we need to convert to world space. We don't need the tangent. Position normal UV and no light map. Is that all? Yeah. And then, okay, so this will stay the same. Oh, in the height map, I never fixed the shadow caster thing. Okay, I guess let's go. Yeah, that was a kind of important bit. So yeah, it's, I guess, declare identifier height map. Okay, it's gonna just, I guess we can just ignore it for now. You're creating a game for mobile and have some problems with shaders and draw calls. You tried to use multiple versions of a shader for ambient occlusion, metallic, normal mapped, but you found out that the SRP batcher doesn't work with multiple shaders. So sampling a texture is expensive for mobile. It's okay, Attempted. I don't mind. Yeah, I think for batching, everything has to have the same shader, and that includes like variants. So even if you turned off different keywords, it won't batch them. I'm pretty sure. And sampling texture, I don't know if it's more expensive specifically for mobile, but in general, sampling a texture is kind of expensive for any shader. So you want to keep it as low as possible. So I'm trying to think what the best solution for you. Yeah, I mean, I guess you would generally for batching, it'd be good to have everything use the same shader. So you could maybe try that, and then if you still need to optimize, I'm trying to think what I would do if I had to optimize more. I guess I would maybe have a version without normal mapping, because that's probably the most expensive out of all those. But yeah, that will break, like you said, that will break some batching, so it's kind of a balancing act. What was I gonna look at in here? Oh yeah, I was thinking about that error, but okay, so what I need to do, oh right, I was gonna turn shadows back on. So have shadows. Actually don't see any weirdness. Is the Shadowcaster working? Because now this is flat. Let's see. Okay, so something's wrong with the Shadowcaster because it's showing up as flat here, even though this is obviously not flat. Yeah, they don't batch materials with different keywords, I'm pretty sure, so yeah. You need to try to keep everything with the same variant if possible, even if that means doing a few more texture samples. It might be faster in your case. Why? What's going on here? I thought that it was working a second ago. Let's see. It definitely was before. Frame debugger. Oh, yeah. Need to have game view open. Okay. Oh yeah, this doesn't really work super well in Eurp. Let's see. So tessellated height map. It's definitely running. Why does it run twice? Oh, for cascades. But yeah, we can't really see it on the texture. It's a bit of a shame. Let me turn on ambient occlusion. Okay, so that is running correctly. depth? Hard to tell. Oh, well, it's the... Oh, okay. Well, maybe that was the issue. It was working. It's just like light was in a weird angle. Yeah. Okay, so that was kind of silly, but... Okay, so the shadows are working, but I'm trying to see... I don't see that shadow error anymore. I guess it's not as visible when the normals are fixed. Or, yeah, like the normals don't work right now, but you know, they work. They're kind of there anyway. Let's see. Yeah, so I can't tell you the difference, but... Oop. Sorry about that. Thanks, Adam Toot. Yeah, I think it's getting there. Let me see. Yeah, I think I need to fix this normal for the shadow caster, but so basically I just have to do this in the Hlsl function. I guess I'd have to do this whole thing. So can I move this out to its own function? Oh, that's not right. So float 3, get normal. From height map, and we'll deal with the arguments in a second. And then I need to move this function up here. Yeah, except shadow casting. I need to try to fix that bug. Okay, so what this needs is the UV for the center. Which I guess we'll just call UV. And then we need, this is there. I guess we just need the normal and the tangent. So vertex, normal, and float for vertex, tangent. Okay. I think that's all I need. So we turn normal world space. Okay. So what I would do... Okay, so we only need to calculate this in the domain function if we're in the shadowcaster pass. So I can just do float 3 normal. Oh, I already have it. So shadow normal is, oops, get normal from height map. So the UV we have there, and then we have the normal world space. Okay, we don't have the tangent. I guess I'll just calculate this outside. The compiler is smart enough to not do this if it's not needed. So it will strip this away for passes that don't need the tangent right there. But that's depth, I think. Okay. And then pass this there. And declared identifier height map. Oh, it's my other shader. Okay. Not. Oh. Yeah, this has to. We have to do a sample. Oh, that's a really shame because I'm gonna have to make two separate functions. One to call the LOD version and one not to call the LOD version. That's really annoying. UVS float one. Oh. Where did I do that? Oh, you're right. Thanks for catching that. Oh. Yeah, I don't think there's a way I can get around it. Oh, that's annoying. LOD. Yeah, because there's no functional programming in Hlsl, so I can't like pass a different macro or something. Oh well. Oh right, and then I have to pass 0. Oh, and now I need the normal version of sample height. Okay, so now the shadow should work better. I don't know if it's super. Well, I don't really even notice the shadow artifacts, but we fixed it. Yeah, the lighting almost looks good, but then when we change the light to face straight downwards, you can tell something's wrong because it's too extreme. But I'll get on that. Okay, so we had that. Yeah, we had the shadow problems when I set the normal world space just to the input normal. So let's just do that and maybe turn off. Okay, so yeah, I don't notice any shadow problems, which is good. It should have self-shadowing if I turn the height map up. Okay. Oh yeah, some of this is just, you know, shadow maps are never perfect. But yeah, I don't see any big issues. It's still sort of ugly, but some of it would be fixed also by the lighting. And the more fine-grained you get it, the better it does. Anyway, it almost looks better with just the shadows instead of doing the lighting algorithm. But anyway. But I think I need to sign off because I've got to go do some stuff before my day is over. But yeah, thanks everybody for coming by. I hope this new time today isn't too much of a bother for everyone. I don't know for sure if I'm going to keep it. But I thought it was either stream this time or not stream today. So I should be back Monday. Although again, I have an appointment during my normal stream time. So maybe I'll stream in the afternoon again, but we'll see. I might have to move it to Tuesday. Yeah, I'm really sorry. I want to start streaming consistently, but it's just been difficult with my schedule. But anyway, yeah, thanks everybody again for coming by. I'll put links in chat if you enjoyed the stream and you'd like to connect with me on any social media. Check out my YouTube channel for our game development tutorials. And Monday we'll probably continue with tessellation. Maybe I'll have thought about how to fix some of these problems. But yeah, I hope you all have a great weekend and a great Halloween. And I'll see you later. All right, bye bye.